Alright, so here is limiting reagents and percent yield. I'm just going to read this problem, and you can play it back as many times as you want if you want to write it down so that you can see it as well, but I'll work through all of the different parts. So the problem says solutions of sulfuric acid and lead-2 acetate react to form solid lead-2 sulfate and a solution of acetic acid. If 5 grams of sulfuric acid and 5 grams of lead-2 acetate are mixed, calculate the number of grams of sulfuric acid, lead-2 acetate, lead-2 sulfate, and acetic acid present in the mixture after the reaction is complete. Alright, so the first thing we got to do with this problem is write out our chemical equation and balance it. So our first one is sulfuric acid. It's not hydro, so we know that it's not just sulfur. It's the polyatomic ion, SO4, and that's got a 2 minus charge, so that's going to be H2SO4. That is going to react with lead-2 acetate. So my lead is going to have a charge of +2, and acetate is C2H3O2. That has a 1 minus charge, so I'm going to have 2 of those. Those react to make lead sulfate, and this is a really nice one because the lead is 2 and the sulfate is 2, so it's just a 1-to-1 ratio, and acetic acid, which is just that. We got to go through and balance our equation. So we look here, we have 2 H's. On my sulfate, we only have 1 H that we added there, so we got to have a 2 there. I have my 2 acetates, and I've now got my 2 acetates, so this is balanced. So make sure that you have this written down because I'm going to be using this as I go through, and so that you can refer to it on your next one. So the first thing it says is that we have 5 grams of both of our starting materials, of the sulfuric acid and 5 grams of the lead acetate. And I'm going to shorten this down a little bit and just put ACE instead of all that other stuff. Okay, so whenever you see that ACE, it's just lead-2 acetate, and it's what I had written before, but just to save myself some time. So let's see how much this would be for the sulfuric acid first, and then we'll see how much it is for the lead acetate to determine which one is the limiting reactant. Okay, so we're going to go 5 grams of H2SO4. Make my table here. It has a molecular weight of 98.08 or 0.09, sorry, 09 grams per mole. And we're going to switch this one. We're going to compare it to the lead acetate. So we're going to do that here. 1 mole of my H2SO4 is equal to 1 mole of my lead acetate. And this is really nice because 1-to-1 in most of it. The only one that's not is the acetic acid. When you calculate this out, if I start with this much, I can react that with 0.0510 moles of my lead acetate. So now let's look at my lead acetate and see how much that does to see if it is my limiting reagent or not. That one is also 5 grams. And this is my PBACE. And that one has a molecular weight of 325.30, so a lot heavier than my other guy. Which means when this one is all worked out, it is 0.0154 moles, are all that you get there. So this is definitely going to be my limiting reagent. If I take that and minus it from, oh wait, no, so this is my limiting reagent, so by the time everything's all the way done, I'm not going to have any lead acetate left. It's going to be all gone. So that's part one of the question, is it wants all 4 of the things in our chemical equation to say how much of those are we going to have. This is my limiting, so it's going to be all gone. And I'm going to use this number to use all my other calculations. So everything is going to start with this number from now on. Alright, so we're going to go with 0.0154 moles of my PBAs. Okay. To see how much of my sulfuric acid is going to be left over, I'm going to switch it back over to my sulfuric acid. So 1 mole of my PBAs to 1 mole of my H2SO4. My H2SO4 was 98.09 grams in 1 mole. So when this is all done, I will have used 1.51 grams. That's how much I used. Remember, I started with 5 grams, so we're going to subtract those, and I will be left with 3.49 grams of sulfuric acid when this is all said and done. Okay, so there's number 2, the second part of the chemical reaction that I know. Go back to what my limiting reagent was, 0.0154 moles of PBAs, and that's acetate again, just to remind you of that, which is that C2H3O2 with a 1 minus charge. I have 1 mole of that for every 1 mole of lead sulfate, and that's PbSO4. That has a molecular weight of 303.27 grams in 1 mole. And so I will have produced 4.67 grams of my PbSO4. Okay, so there's number 3. And the last one, the acetic acid, 0.0154 moles of my limiting reagent, my lead acetate. 1 mole lead acetate, and this is from your balanced chemical equation, to 2 moles of my acetic acid. My acetic acid has a weight of 60.06 grams in 1 mole. And so I will have produced 1.85 grams of acetic acid with this reaction. The last thing it says, if my theoretical or my actual yield is 4.50 of the lead sulfate, what is my first theoretical yield, which we already calculated, and percent yield? My theoretical yield is just what we did when we did the lead sulfate, and that should have been 4.67. Okay, so that is my theoretical yield. My actual yield, they said, was 4.50, and it is actual divided by theoretical, so we're going to set that up, 4.50 divided by 4.67, and times that by 100, because it's going to be that percentage, and we'll end up with 96.4% yield. Alright, so come in tomorrow and tell me if we want 1 more of these, and I will put it on if we do. And we'll see you guys on Friday.